Thanks everybody for making the time. Um, really appreciate you guys choosing to be here. It's really awesome to have Zach and Charles here with us as well. I'm going to go ahead and just kick things off and kind of get right down to it. I wanted to take a quick second at the top just to let everyone know we have added a new section on the forum for funding opportunities and collaborative agreement opportunities. This is really a ripe area for discussion, I think. One of the sales leads here, Tosca, at Sofar, has been kind enough to suggest this idea and also seed it with a couple of interesting opportunities. There's one that's imminent if anybody is in Florida or doing work in Florida. There's one from the EPA in Florida, and there's a couple of others. And we'll be posting things there from time to time. These are not always things that Sofar would be interested in, but there are things that we might want to collaborate on. So if you haven't had an opportunity to go head over to that section, it might be worth keeping an eye on that or setting up an alert whenever anything new is posted there. I think almost everything that we've posted there could be applicable to pioneers and specifically around some of the work that folks are doing, but not necessarily you know something that's easy for everybody to immediately sign up for. So if you see something you're interested and you're like, wow, I'd like to learn more about that, let us know and we can engage. And kind of some of these we know better than others. But check that out. That's really cool. We hope to kind of keep that going. And that's really in the spirit of Bristlemouth as well. We're trying obviously to connect people as well as things underwater and in the water. And so this is a great way to work with fellow pioneers or other companies in the space and get something cool done and hopefully get a little funding to further the work that you're doing as part of the Pioneer or otherwise. Well, anyway, I wanted to get right down to it. We've got some really fun and super exciting things that we're working on, and we've been lucky enough to have Zachary Crockett and Charles Cross here to join us to kind of tell us about those. We're going to leave some room at the end probably for Q&A. And again, this is Q&A that could be general. So if you just have general questions, it's all on board. And you can also post some questions throughout in the chat window and we'll kind of stop and answer questions about the presentation or just in general at that time. So I don't want to take up any more airspace here. I'm going to turn it over to Zachary Crockett for a quick introduction for those of you who haven't had a chance to meet him. And I think he's going to show us a demo.
All right. Thanks, Zach. Welcome all. My name is Zachary Crockett, and I lead the firmware team at Sofar Ocean. And a big part of my job is pushing forward Bristlemouth firmware. So as mentioned last time, we are starting an initiative to make Bristlemouth easier to approach and use. And one of the ways that we're doing this is by enabling more effective use of an application coprocessor like an Arduino or a Raspberry Pi. We floated this idea. Lots of people chimed in saying, yep, that'd be helpful. And connecting that to a dev kit over serial, and then trying to get some of the more core Bristlemouth functionality accessible easily to that coprocessor. So today I wanted to show off something that I built this week. I have, let's see, got all the wires here. It may not work terribly well to actually show. Yeah, I won't bother. Maybe over here, there's a bunch of things with wires that are being blurred out. Oh, here, turn off the blurring. Okay. Yeah. Okay. Got a bunch of things connected here. I have an RP2040 purchased from Adafruit, just a standard microcontroller that's easily accessible, and a dev kit and a spotter board stack because I'm a core developer here, so I have all the guts of the e-box taken apart. One easy way to get started writing code for this RP2040 is with CircuitPython. And I don't know if anybody here has used that before, but it's really easy. Once you install the Python firmware, the board just shows up on your computer like a USB drive, and then you can put Python code on that USB drive that will run at startup to blink LEDs and talk over a serial connection. So the first thing that I wanted to make as easy as possible from this Python code was sending real-time telemetry using Spotter's cellular or satellite connection. So that's a common use case. You've got your Arduino or whatever it is, you connect a sensor, and you just want to get it through the Bristlemouth network out to a server and somewhere where you can actually look at the data in real time. So I'll share my screen here. Oh, there we go. There we go. All right. So get the windows in the right place here. So I wrote this super simple Python program. This is the Mu editor that Adafruit recommends, so nothing specific to Bristlemouth. And I think everybody ought to be able to approach this tiny chunk of code pretty easily. We've got an LED. There's this little line to say, oh, create a Bristlemouth serial object. And then we just repeat basically this one call where we say BM spotter TX and give it some set of bytes that you want to send. This could be the payload from your sensor data, whatever it is. And this works right now. It goes through that serial connection over to the dev kit. The dev kit republishes it on the Bristlemouth network. Spotter listens for that, sends it out over telemetry, and the messages appear in the raw messages API that's described in Guide 5. And the code for this that got this working involved a couple of things, but nothing too huge. It's all open source on GitHub under the Bristlemouth organization. One, in order to create this BM serial Python library that you have to drag the Python file onto this is the RP2040 showing up as a USB drive here. So code.py is what I've got over here. And I had to just drag this BM serial py into that lib folder, and then I can include it here. Even that file is not that complicated. It does some of the low-level encoding of how to get the bytes just so that the dev kit sees that everything checks out. There's a CRC and all this stuff. And then on the dev kit side, I created a new app that's in the dev kit folder that you can build if these are open pull requests. They're not merged in to the develop branch. They're not released yet, but the really basic app, all it really does is proxy those publishes, those Bristlemouth publish things that you send over serial on to, here's the callback that gets called when serial data arrives that looks like a publish, and this just republishes it back onto the Bristlemouth network. And so that is all. I just wanted to show off that, and I hope it makes people's lives easier. I hope it gets people excited, and I look forward to any questions. Maybe I'll hand it off to Charles for now. Go ahead.
Yeah, that's super awesome. Charles, I'm going to cut in right before you start. So Zach, I'm assuming this is part of a release or something coming up, and we're calling this like BM serial, right? Is that right?
Yeah, so there is already a library, a repo in GitHub called BM Serial, and it is C code to send lots of different messages back and forth over a serial connection. And I can add more to both of these libraries, the CircuitPython library and the Minimal Bridge app, the Serial Bridge app. Right now, it's only that one publish coming from the dev kit in, but that's a starting point. That repo is called BM Serial, and so I added a CircuitPython folder to the BM Serial repo. So But yes, BM serial, if you say BM serial, then that means a repo that we've got up there for talking over a serial connection. And if you talk about CircuitPython, that'll be where that lives. Yeah. And yes, we will get this out in a release sometime soon.
Awesome. I'm sure some folks on the call are really excited. I think I saw, yeah, Vince is there. It might be very interesting to him and the high school students to be able to program on a Raspberry Pi, build an app, all on that side with code that they can borrow from other places and best practices. And then using this new interface, they're able to simplify the amount of work needed to send messages right to SD card, all that fun stuff. So this has been like one of our most requested features, and I don't want to undersell it at all. And hopefully this is the beginning of a lot more access to people who otherwise would find Bristlemouth maybe a little too challenging or too time consuming to get things done that they want, or they have an application already written or developed for some of these other platforms that they can interface. So want to take a quick second just to contextualize all that before I hand it over to Mr. Charles Cross. So Charles, if you please introduce yourself to folks who might not have met you and take it away. Really excited to hear what you're going to present as well.
Awesome. Thanks, Zach. Yeah, so my name is Charles Cross. I'm the CTO at Mission Robotics. We help with the design of mostly the protocol layers of the Bristlemouth stack. And what I'm going to be talking about today is kind of the other prong of the fork that is accessibility. There's one aspect which is making it easier for people to like actually write code and add their sensors, and not have to be embedded system gurus to work at like the RTOS layer and all that kind of stuff. And that's where the BM serial approach that Zach just described is targeting and like really solving that problem, letting you work with CircuitPython, et cetera. Where I'm going, what I'm working on right now is the aspect of being able to bring Bristlemouth to more platforms. So right now, the code base for Bristlemouth is very tightly coupled, and like the protocol libraries themselves are pretty tightly coupled to free RTOS running specifically on the STM32 chip that is on the mode that you have. So the question is like, how do we make it possible for Bristol to use on other microprocessor families or other platforms altogether, like Linux boards, etc. So I'm kind of focused on the how do we get Bristlemouth working on Linux aspect for two reasons. One, it does open up more avenues to more easily develop Bristlemouth code. Once you're in the Linux space, you suddenly have the freedom of many different types of languages, whether it's C, C++, Python, anything else. You kind of open up into the ecosystem and no longer have the constraints of microcontrollers as far as like memory and language choice and tools and frameworks, libraries, etc. The other aspect of it is opening up new applications because you have a more powerful Linux processor. Now you can do things, well, there are more powerful microcontrollers now that can do some of these things, but in general, like accessing camera devices, processing high bandwidth data, doing things like machine learning, computer vision, opening up the Linux processor space really, helps to get into some of those applications that you couldn't necessarily do today with the moat that we have. So real quick, just a recap, because I shared, share screen. I shared a post on the Bristlemouth forum November of last year. So let me share that window. Just to give a quick recap. So in the past, I had done some initial prototyping on Linux in this post, if you search for Bristlemouth native Linux support. And what we had kind of used was this dev kit that allowed you to go from basically an Ethernet interface on your like Linux development machine, or it doesn't have to be Linux specifically, but in this case it is. And then it converts it into the 10-base T1L signal that is being used for the Bristlemouth communication protocol. Since that point in time, there are now many USB and SPI to T1L adapters that are off the shelf that you can buy. They don't necessarily handle the power aspect, the power delivery aspect of Bristlemouth, but there's some ways around that. And then on the software side, I built kind of a command line interface that allowed me to discover devices in the Bristlemouth network, get their heartbeats, send my own heartbeats, allow them to discover me, and send some various power information or various pub sub information. So where this is going now is we basically want to get the Bristlemouth library to a state where, like I said, it can be used on different platforms. So part of that involves refactoring the library and splitting it up into different components. So we've got kind of like the aspects that need a platform abstraction layer. So on the moat/spotter, I'm using FreeRTOS as my OS. I'm using LWIP as my IP stack library. And then on Linux, you know, it could be on a Raspberry Pi or your PC. The OS is Linux. We're using, in this case, I'm using Linux raw sockets, but there's other ways to do this as well, like serial ports and whatnot. So abstracting all of the system/operating system calls and network abstraction details away from the platform, so that all of the Bristlemouth libraries, regardless of what they're running on, can perform all the functions necessary to send, receive packets, and exercise things like that are necessarily at the OS level, making packet queues and buffers and handling memory management, all that kind of stuff. So all the messy details that no one wants to deal with, and basically making it so like these are more simple libraries that have specific functions that don't care about the underlying platform they're on. So what is this like? There's like the approach of writing this library right now, and you know, to make it cross-platform, you want to write it in C, and you have to like do a lot of work and to get to all these individual abstraction layers built out so that they work on all these platforms. We're not immediately jumping into this body of work, but what we're focusing on is making a quick version of the Bristlemouth libraries that work specifically starting on Linux, that implement the architecture laid out roughly in this diagram here, to make sure we have the divisions of responsibilities appropriately split up. Once we feel good about that and like how we can support different types of network devices, like whether it's serial or these T1L adapters, and making sure that we can you know, handle everything on Linux appropriately, and we've got the like the multi-threading and stuff set up for all these different tasks that the Bristlemouth library has to perform, and the client API is looking the way we want them to. Then we'll go back and convert this into like that perfect like platform abstracted library that can be used anywhere. Initially targeting, of course, the moat/spotter as it is today, plus a Linux target. Right now, we're really looking at the Raspberry Pi Zero family of processors, just because of their size and power requirements. Like they're almost like a perfect fit. And there are some off-the-shelf SPI to T1L adapters that you can like put on the Raspberry Pi Zero header, and it'll basically get you directly onto the Bristlemouth network natively. So a quick diagram of like what this kind of opens up as a user. One aspect, you'll be able to more easily introspect and debug your Bristlemouth network. So assume that you've got your typical like spotter and then a series of moats in your smart mooring deployment. You know, there's an unconnected Bristlemouth port both on the bottommost link as well as the spotter at the top that could potentially be tapped into at the T1L layer. So you could have your laptop/development machine use one of these USB T1L adapters, plug into either end of your network, whether it's like in the water functioning, so you can see things happening in real time, or it's on your desk and you're just doing development, testing all your devices. This would get you native access into the network. And then the other approach is on the other side, supporting, like I said, like a Raspberry Pi Zero using either a SPI or USB based T1L adapter. It requires a little bit more electronics to break apart the power and the comms aspect, but this is like a pretty simple board that could be spun out. So that would get you a Raspberry Pi Zero like in your Bristlemouth network. So you could attach a camera at the bottom of your chain, and now incorporate that into your network. Then the third approach is making a flavor of the Bristlemouth network driver that supports serial interfaces. So right now, like we mainly operate over Ethernet frames, but there's no reason you can't pack Bristlemouth data into serial packets as well. This is different from what Zach Crockett was talking about in terms of the BM serial library. That is a standalone, simplified subset of the overall Bristlemouth capabilities. What I'm talking about here is like putting the entire Bristlemouth protocol natively, all the underlying control messages and discovery messages and all that stuff, natively working over a serial interface to your moat. So then you could take power and your UART connection off your moat and attach a Raspberry Pi Zero here. The disadvantage of this approach versus getting it actively on the T1L network is you've got higher bandwidth and you've got more like two connectors to deliver your power. The whole thing about the Bristlemouth connector as opposed to a separate power and UART breakout on your moats like payload interface. So these are like kind of the three topologies that'll get opened up. The two that I'm focusing on are the serial interface and the debugging interface. And part of this effort, both to help development and to serve as in the long term as a tool for users to, without having to write any code, introspect, manage, test sending and receiving messages. I've started building a program called BM GUI. It's very early stages right now, but just to give you a quick idea of what it will kind of look like, you basically open it up, you set your node ID in the system, so you can just like kind of randomly generate or type in your unique identifier for your laptop. You can start the node with that ID, and then you have the ability to add any number of new connections, and it'll automatically discover the available interfaces that you have on your machine that support doing raw socket communication. So I can like choose my Ethernet interface, add that in, turn it on, and now if let's say that this was an Ethernet interface connected to one of these USB to T1L adapters, and that was connected to my Bristlemouth network. Now I have a network connection into my Bristlemouth network, and we'll be building out all the functions to like show here's all the peers I've discovered. Here's all all the low level send and receive and Bristlemouth control protocol package can send. But more excitingly, being able to go into like this middleware tab and discover all the topics everything is publishing, being able to create like your own publishers without writing any codes. Like I want to create a publisher on this topic and being able to just like type in the data so that you can, let's say you wanted to pretend you had developed a temperature sensor. You could like write a script to publish fake temperature sensor data here to validate the rest of your solution that you've designed. So this is designed in the long term to be both like a debugging tool as well as a development tool so that you can, without writing any code, quickly test and deploy and get a feel for whether your solution is going to solve your needs without having to get any hardware like in the water necessarily. So it's kind of like an admin console, if I could sum it up. And one of the cool things is like for these Linux boards, if you've got multiple USB to T1L adapters, you can come in here and like add as many network interfaces as you have available. And so now this also opens up the ability to have Bristlemouth hubs. So you could basically, if you had 3 of these adapters, now you can create a fork in your, as opposed to just like a daisy chain topology, you could fork it into multiple branches of a tree. Another interesting side effect that came about, if you notice, this specific interface on my Linux machine is a 0-tier interface, which is basically kind of a network bridging VPN sort of solution that allows you to peer-to-peer communicate between machines over the internet. So you can like set up your own little private network. Because this works with like basically seamlessly with 0-tier, you can now connect 2 remote Bristlemouth networks remotely by adding one of these 0-tier interfaces on here. All of the discovery traffic, all of the Bristlemouth traffic will be restricted to and will flow through that 0-tier interface. So you could have something literally on the other side of the world that's part of your Bristlemouth network. So that's kind of an exciting aspect that's coming out as part of this. I know I touched on many different things, but basically unlocking this Linux support is going to open up a lot of new capabilities where there's like more powerful sensors, processors, devices, but also some new interesting network topologies. Now, it's going to be a little bit before like some of the hardware is there, besides some of the off-the-shelf stuff you can buy to handle things like power and comms breakout. Some of this stuff is pretty easily blue wired. Great questions to ask about like on the forum. There's plenty of people who can figure out how to quickly stand some of this stuff up. But that's kind of where we're at. And I think that's what I've got for today. I'm happy to answer any questions about any of this.
Oh, that's massively cool. Thanks, Charles. I think the potential of things that this opens up is really kind of order of magnitude greater than what we're capable of doing now. And I think some of the folks listening might be excited to hear this. This is kind of paving the way for massive interoperability with other systems that we just can't get to yet. And it was something we've always wanted to do. So I'm super happy that you're able to come and present. Thank you so much for that. So what I'd love to do is switch over to questions. I think we've actually already got one in the chat window here from Andre. Andre, great to see you. Thank you so much for the suggestions for co-processors in the forum. definitely good advice. I think we're headed that way. And the question is it possible to give a list of 10 base T1L adapters that you've used? I'm assuming that's for you, Charles.
Yeah, I'll in the background, I'll paste a few links in here to the ones that are like at the top of my list. Now, I haven't tested any of these yet, but they should be generally working.
Awesome. And I think we've got another question from Alexa. Go for it. Alexa, you might be muted. Let me see if I can unmute you. Actually, I'll let you. That was an accidental question. Awesome. Okay, no worries then. Won't put you on the spot there. Zachary, I've got a question for you while we're potentially waiting for other questions. When do you think I can start testing the serial library on my own Raspberry Pi? No hard commitments, just
Yeah, no, I mean,
ballpark.
you want to try it today? I can help you get it set up today. It's
Okay.
If you want to wait for an easier path, it might be like all the way to a release with a clear written instructions. That might be July, but
I might wait until July. I'm not as brave as you are for some of that programming. Okay, that's good to know. So it's coming down the pipe.
Yes.
Awesome. Great. So Charles has posted in the chat window, Andre, some of the bridges that he's been using.
Yeah, so the top two are USB T1L adapters, and the bottom one is a SPI T1L adapter for the Raspberry Pi. It's a Shield, which is it's a modification of one that was, I think, made on SparkFun or Adafruit, one of the two. But yeah, there's a lot of these are coming out. They're, now that there's like good, better T1L adoption in the overall market.
Great. Well, if there are no more questions, we might, I think we're mostly on time. Yeah, we're on time here. So I think we might just call it a little bit early and let everyone get off to the rest of their day. It's just morning, 10 o'clock in the morning here on the West Coast. So
Yeah, I see that, Andre. I have the links. I'll throw them in the forum unless you want to, Charles.
Yeah, I'll throw them in my Linux post. So if you search for that, but I also then just resent it hopefully to everyone. But I will put them on my post as well.
Well, unless there's anything else, I want to thank you guys for coming to present. Zachary and Charles, thank you so much. It's always great to have you. To everyone who decided to spend their mornings or afternoons or other times, depending on where you are with us, thank you for making that choice. That was really great to have you. We'll throw this recording up on the forum, and obviously, if there are any questions that come up, we're happy to answer those, and let us know if you're running into any blockers or trouble with any of the work. If you are a pioneer, we're happy to help get you unstuck and get you moving. Take care, and I'll talk to you guys later.